I invite Srimati AGM from Bell for the presentation.
Good afternoon, ladies and gentlemen. Yeah, I am from Bharat Electronics. My presentation will cover these things, a quick overview of Bell, and I am from an SBU called Electronic Warfare and Avionics. We are mainly working on avionics field, and what all facilities we have, and I will cover what are the challenges in avionics and how industry can participate in avionics along with Bell. BL established in 1954, and it has 9 manufacturing plants, and we have a very good R&D base. We have a 3-tier R&D structure in Bell. We have R&Ds or development and engineering groups as part of the manufacturing units, and we have a central research lab, and we have a product development innovation center which do development of technologies, and central research lab to do blue sky research. And we have, out of our 9,700 employees, 50% are engineers, and out of that almost 47% are in R&Ds. We are a multi-discipline, multi-product, multi-technology company. We have presence in radars, missile systems, communication, electronic warfare, network-centric systems, electro-optics, and homeland security. And we have generally our production, if you see, 80% is for defense. Except for last year, we had almost 40% in the civilian thing. We supplied electronic voting machines to Election Commission of India. Geographically, we are present in the south as well as in the north. We have got, Bangalore complex got the CIA Role Model Award last year, and we have Six Sigma, PMI, CRE, CQE, all those things embedded in our system. Our software development centers are CMMI level 5 certified, and 7 of our units are certified for aerospace standards AS 9100, and all our centers are certified for ISO 9000 and ISO 14000. And we also have shop floor quality improvement programs. This, as I told, we have a strong R&D presence, and we have very good infrastructure and simulation tools, setups, etc. And we have a very robust quality systems, and we upgrade our manufacturing facilities continuously, and we have very good quick absorption of technology. Like many of our systems are based on DRDO technologies. When we come to electronic warfare and avionics, we generally, we mostly supply to Air Force. Our radar warning receivers are used in almost all the fighters of Indian Air Force. And we have an LCA division. We supply to Tejas, this digital flight control computer, air data computer, etc. Almost 10 LRUs we are supplying to LCA. We also have a communication intelligence wing. We work for the Samyukta program, and we are into the UAV electronics also for Lakshya, Rustum, and all ground control station we have. We are jointly producing with ADE. Newly we are going to enter into aerostat and payloads for UAVs. And we have also a strong association with ISRO. Recently we have been executing a contract for the assembly and integration testing of satellite, and we are planning to establish an ecosystem with in future it can grow as a vertical, and we may make satellites for ISRO. That is our plan. And if we see our ecosystem, as I told, we have a very strong quality management system, infrastructure, we have very good trained, skilled manpower, and we have our product support to the customer is our USP. These are our assembly facilities. We have a clean room, highly ESD compliant SMT line, a loom assembly, and we have inspection facilities, X-ray facilities, and we have very good testing lab, and we have all the ESS facilities in our campus and antenna test facility, etc. Now, why I am telling you all this is, and we have also assembly operators who are certified by IPC specialists, and our DGAQA has given approved vendor, approved inspector certificate to most of our people. So with all this, now our order book, overall Bell order book, if you see, it is more than 5,700 crores. And with no more recruitment not happening that much, it is very imperative that we have to look at industry to give us support. So many of the things we have to get it done through the industry. And before we go into that, I want to tell in the next 3 slides what are the challenges in avionics, because avionics is a very tough and a difficult field. Right from procurement to assembly, execution of any avionics product is a big challenge. Most of the components are imported. That is obviously known to everybody. And mill-grade components are more and more becoming non-existent, because OEMs are stopping mill-grade components. And elaborate screening methods are to be carried out to use the COTS components. And when all these are low volume requirement, and we end up with high cost increase as well as storage requirements, and in that process we come across counterfeit components also, so which calls for much more elaborate inward inspection, etc. And we also have a kit clearance before starting of the assembly to ensure that the components what we have supplied are all the right ones. And any time whenever a new product is introduced, extensive flight evaluation, qualification procedures, these are very cumbersome and long duration processes. And we have lot of single vendor issues, let it be components or subsystems. And whenever there are single vendor issues, we have issues of long lead time, and repair cycle time is also very long. And when you come to processes during production, again, to make sure there is zero defect during usage, the design approval process is through Semilac, and we have a very laborious qualification procedures, then independent verification and validation for software and flight trials, and DGAQA inspection, which is in-house. They are part of us, and in each and every operation they are to be involved. And ESS or environmental stress screening is done active, like during vibration and thermal cycling, we have to monitor the parameters. And whenever there is an obsolescence and whenever a component change or any SOP change, we have to do limited qualification tests and PQT or production qualification tests for if we start a line after some time. And there is a lot of record keeping which is a must for avionics, and the traceability across the complete supply chain is to be ensured. And whenever there is any failure in-house or in the field, a very detailed defect investigation is to be carried out. So when we partner with the industry for avionics, all these aspects have to be followed by the industry also. So that is the mandatory requirement. You have to have a very good ESD compliant and clean room facility, trained manpower, and adherence to all these processes and procedures is a requirement. And when we outsource, we do it, we can divide it into three parts. One is outsourcing or procurement. Procurement is still primitive because off-the-shelf components will be procuring. Next is outsourcing. Second is vendor development. Third is collaborative R&D. Outsourcing of products as well as services. If you see outsourcing, it is either off-the-shelf items we may be procuring. Items could be generic like power supplies or add-on cards, or maybe some ATE development we may outsource. And outsourcing of services is when the capacity is not adequate, even for some IV&V we do, or PCB CAD, signal integrity analysis, or wiring and cable harnessing. These kind of things are outsourced. And for most of the mechanical manufacturing processes like painting, plating, welding, etc., without raw material, we use industry. These are the basic level of outsourcing. Next comes the slightly higher level, which we cannot call the industry partners as vendors, we call them partners. These are, this process is called local vendor development. This is mainly done for import substitution, for critical items or subsystems during the production phase. It is also part of our indigenization drive, and it will also address the obsolescence management. And whenever we have to give long product support to customers, so this vendor development, we have taken it up for the last few years very seriously. And next higher level is a collaborative R&D partnership, where technology modules of strategic and complex type, they are given for development through collaborative R&D process. Industry, academia or design houses, this is done through a collaborative R&D process. There is a slight overlap between these two, vendor development and collaborative R&D process. As Government of India also advocates us to do, we are into indigenization drive in a big way. We have committees formed in all the SBUs, and we form small committees within each group to identify which are the items to be indigenized. And these are, as Madam Tenmudi was telling, we have put up all these things in our BEL website. And once the items are identified, these indigenized vendors are identified through an EOI process or through collaborative R&D process, either based on NCNC demo or based on a development order. These items are developed by the vendors, and we do an extensive vendor audit to assess their capability. Next comes the SEMILAC and DGAQA process, for which all these requirements are already detailed in our RFP, and we also participate along with the users and customers in all the design reviews, evaluation, etc. And a detailed outsourcing document is also prepared. And in all these processes, especially in the certification process, all around support is given by the BEL to the vendors. And finally, we will, as per the RFP clauses, manufacturing or maintenance TOT will be taken from the vendor, so that BEL will be able to provide a long-term support to the user. This is slightly higher level, wherever we have to have a technology module to be developed by a academia or a design house, we enter into this kind of collaborative R&D thing. If you see this, 237 firms have been identified and shortlisted. In that, 77 are MSMEs, and we have over the last 2-3 years, we have identified some 115 projects with the 104 collaborative partners. This is done through our technology planning department. Here also through the website you can apply or give the details for empanelment as a collaborative R&D partner. Here also the process is same. Once the partners are identified, the detailed EOI is given, and based on the responses, detailed SOW and TCA they are finalized, and we give the RFQ to the partners, and based on the different proposals we get, we identify the partner and the release of purchase order, and further processes will follow. As per the ministry advice, 20% of our procurements are from MSMEs. This requirement we are able to meet as on today, and we conduct also MSME meets every year, and this indigenization list is also there in our website. Probably it is not updated of late. This September, October, this is going to get updated. And unit-wise nodal officers list is also provided in the website. I will briefly tell you now what are we expecting from the indigenous vendors. Other than those requirements, whatever I told, like your adherence to all those quality requirements, we need to have adequate infrastructure for testing, etc. You need to have qualified and skilled manpower, and labs and simulation tools, prototyping facilities, etc. And the knowledge on reliability, knowledge on validation processes, procedures, design reviews, etc. is required. And very important is you have to adhere to the timelines. That is where most of the times we have problems with the vendors is the timelines, and complaints to stringent quality and reliability standards. And all these ATP, QTP, Iesas, all those procedures and processes, that knowledge also is a requirement. And what support will be provided by BEL is, we definitely, if we have any development tool or already if it is available, that definitely will be shared, and test facilities will always be shared, and all the Iesas facility infrastructure will be shared, and we give training programs on systems and procedures, ISO or AS9100, etc. And R&D capability, like any simulation studies or analysis, that support also BEL will provide, and all your CRI, SEMILAC procedures, processes, adequate support will be given by BEL. Finally, I want to conclude saying that we are very keen to complement the capabilities of Indian private industries, which is very vibrant, and we want to create a very good manufacturing ecosystem for defense technologies. Thank you.
Thank you, madam. I think question and answer session can go offline because all the speakers will be available in the hall. You can meet face to face and discuss. Thank you, madam. Moving on to next presentation, I invite Srimati Suma Santosh, Head is EWCD VSCC Trivandrum.
Good afternoon, in the name of Jesus. I am Suma Santosh, representing the Indigenization Division of the Avionics entity from the Vikram Sarabhai Space Center. Actually, as all of us know that now India is seeing the launch vehicle programs, and we are the design and development of the launch vehicles, right from the PSLV and up to the LVM-3. And also we are now taking the re-entry launch vehicle, RLV mission, and now we are moving into the human space program also. Basically, the electronics is mainly involved in the avionics entity, And we have the different, I have not prepared that slide. Avionics entity is mainly comprising of the navigation, guidance and control processor. And everything is based on the 1553 bus. And there is the telemetry and the tracking systems are available. Then there is an RF systems are available. That navigation area, it is now dealing with another session which is called the IASU inertial, that is in the Trivandrum itself. And our mainly is mainly upon the guidance and control processor. And in our this navigation and guidance control processor, that NGCP, that is mainly based upon the Vikram 1601, now this one, and it is being indigenized in India through the SCL Chandigarh. More than about 8,000 components are there in existing in the different packages. And we have one flight itself, more than 80 packages, onboard packages are available. Different type of sensors are available. Sensor packages and data acquisition systems are available. And we have been indigenizing only for the last, from the 1996 onwards, we have been indigenizing the different various electronic components. About 250 components have been indigenized from the 1996 till date, and most of them have been inducted in the onboard computers, and which will be flowing in the different launch vehicle mission. But the components that yet to be indigenized is very vast, because most of the components are getting from the imported, mostly are imported. The topic of presentation mainly is, that is, what are the items, electronic items that is indigenized in the past, and what is the ongoing activities now going on, and the new proposals, and we are wanted alternative source for this indigenization. That many components, I have listed only a very few only are there due to the lack of time. That is passive components, very few resistors are indigenized. And then mechanical relay, recently we have developed and qualified and inducted into the onboard packages in the one launch vehicle that is yet to fly, that is a small scale launch vehicle, that is SSLV, that is the low current relay, latching 2 ampere relay pin and hook type through the CI Guardian. And 1553 pulse transformers we have this, through the CompuPower Bangalore, that is also being inducted. Then the RF components, we have a lot number of indigenization has been taken place in this RF component. That is mainly from the Bell Bangalore, that is the then SAW filter, then quadrature coupler, S-band power divider. Then recently we have that indigenized that C-band cavity filter through the Flick Microwaves Hyderabad. And we have a vast amount of the oscillators also, sine wave oscillators, TCXOs from AEL, I have limited only I have put. Centum TCXO is there. Then various connectors, the 317 pin umbilical connectors, 127 umbilical, 61 pin push-pull, D38999 connectors, 15.3 bus connector, flat type. So many connectors we have indigenized through the Amphenol. Then we have also this cables and wires, that is PTFE cables and wires, and multi-core and ETFE cables are also this year. Then we have indigenized the antennas for the telemetry systems, S-band, C-band and telecommand through the Verdant and Amphenol. Now the AEL antenna is also being under the fabrication. Then through the SCL Chandigarh we have realized so many ASICs, DAC ASICs, ADC ASICs, soft DAS, and Sigma Delta ADC, and the processor Vikram 1601, that is also been SCL Chandigarh. Another processor, the Kalpana 3201 and Vikram 3201 is already in the pipeline. Then I will be talking on the ongoing activities. Very few only have been listed, and mainly on the chip resistors, the 1206 and 0705, S-band cavity filter, and the non-latching high current 15 ampere relays 2PDT and 2PDT through the CI Guardian. Then wires and cables using the TEMSense. Some cables are already have last week we have received that qualification process from the wires and cables from the TEMSense have been completed. 19 times they have been given. Some more it is now in this one. Then RF cable assembly, this really the RF cable it is now imported and the assembly is being indigenized. That is that we are on the process. First level is completed and the next level of the qualification we have yet to start here. That is through the ADL Technologies Bangalore. Now I will be moving on to the new, what are the areas. Then gallium arsenide FET, that is the internally matched 12 volt, that is equivalent part number, that is FL120MK, that we are looking for. Then the chip capacitors we need. Then MOSFETs are there. FPGAs, now there's 32, SX32 as well as the SX72 and the Pro ASICs. Any vendor from the indigenization is required. This is supplied by the Actel only. Then latching type low current relays equivalent to GP2 and latching high current relays 2PDT as well as the 4PDT and the power hybrid. Then again the micro dot connectors, this is basically it is imported only, that also we want. Low voltage oscillator, that is SMT devices we require. S-band isolators we require. Then power op-amp we require. Then again that chip inductors, the ferrite core beads, then ferrite core bead networks, so many are there. Then looking for another alternative source, we are now looking for the 15-bit pulse transformer. This is only one, this CompuPower only has been given the pulse transformer. This is becoming the major one in the 15-bit line. And the C-band cavity filter, the Flick Micro have given. Again this one. Then D-type high density connectors, we are have more alternative sources are required. The 15-pin, 26-pin, 44 and the 78-pin. Then electromechanical and non-latching relays, that is EI Guardian is the only vendor now available, indigenized this partner. Another source is required. Again the S-band cavity filter also we are seeing this one. Then indigenization, which are already, which is now ASICs, some more ASICs are being indigenized, that is pipeline, but it is not under the hold only. Then ASICs with the Kalpana 32 and the LDO and memory and the 1530 transmitter together, we are already given. And but we would like to have an indigenized, the die has been, the silicon wafer has been procured from the outside, and that anybody, if it is can be developed in the India, that is very, we are looking for that. Then another one is also this year. Then these are the stage controller that based upon the stage, the separation sequence in the vehicle, it is now carried by the stage separation module here. That it is also being now currently we are now this the PCB based. We are now looking for the, we are moving towards the ASIC version. Then control electronics also, that is we are moving through an ASIC. Then telemetry sites also we are having, as such we have the onboard packages with the PCBs, that also we are moving through the ASIC based, through the SCL. Then video system, whatever video it is taken, that is also moving to this one. We have already given to SCL and they will be developing very soon, we hope. That's all, thank you.
Thank you, madam. And I invite Srimati Subbalakshmi, Deputy Director, STAC, Bangalore.
Ladies and gentlemen, good afternoon to all of you. My colleague, Mr. Sudhir, has taken you through a very fine presentation, giving the wide spectrum of activities that ISRO can offer to the industries, both on-board space-based and ground-based. Intelligent electronics, the new frontier, securing our land and space. A very apt and prudent theme selected by Iesa. I am from space department, but I am going to present to you about ground system, that is radars that are developed by ISRO for ISRO's use as well as for nation's use like India Meteorological Department and other agencies. So I am going to talk to you about tracking and weather radars. So the topics covered are operational radars made by Radar Development Area ISRO, then ongoing projects which are being carried out with industry support, then future radars planned with industry. So, precision tracking radars are needed in the launch pad. Prior to every launch, we need tracking radars for range safety measurements, which will give you vital information for evaluating the performance of the launch vehicle and also to estimate the preliminary orbit. And in the launch pad, we also need wind profiler radars to give the wind information like velocity and the profile of troposphere and lower stratosphere below 25 kilometers, and these parameters are used by the Met Department for decision making. And we also need Doppler weather radars in the launch pad, which can give weather information beyond 250 kilometers for pre-launch operations. Now coming to ground-based radars, Radar Development Area is an entity of ISRO Telemetry Tracking and Command Network ISTRAC, which is located in Peenya, Bangalore, and it is involved in the design, development, operationalization and of ground-based radar systems for ISRO's program and also for the national requirements like IMD and other user agencies in the area of weather. Now, RDA can perform the state-of-the-art radar system configuration based on user requirements and also data analysis, weather data analysis, system realization with industry support, upgradation and also R&D for new systems, and it can also provide technology transfer and technical guidance to Indian industry to realize these radar systems for ISRO and other agencies. So coming to Doppler weather radars, they are mostly pulsed radars. They detect the motion of rain droplets, and they also detect the intensity of precipitation during rain, and they provide images of rainfall intensity by measuring the echo. So one example of a Doppler weather radar with a radome is shown. So we have Doppler weather radars in Sriharikota, and we also developed S-band Mark II polarimetric Doppler weather radars by technology transfer with Bell for IMD and ISRO, that is Northeast SAC in Cherrapunji. And some two more S-band radars are located in Gopalpur and Cochin. And we have C-band polarimetric Doppler weather radar at TERL's BSSC Trivandrum, and we have also one X-band polarimetric DWR at National Atmospheric Research Laboratory in Gadangi, Tirupati, which is also an ISRO center dedicated to atmospheric research. Now I'm showing you the 6 radars that are located: C-band in Trivandrum, S-band in Cherrapunji, where the highest rainfall is received, and S-band DWR in Sriharikota, which is primarily used for supporting our launch activities, which I told in the first slide. And S-band DWR at Gopalpur, because in the east coast there is lot of cyclone and heavy rain activities are happening every year. And there is one in NARL, Gardanki, which is dedicated to atmospheric research. And one more S-band DWR is in Cochin, which is being used by IMD. Now coming to tracking radars, there also we have operational radars in C-band and S-band in SHAR and TERLS. And TERLS is where we have the rocket launching for sounding rockets. And these are established with industry support. And PCMC radar, of course, it is there in SDSC, Sriharikota. And we also have new generation precision tracking radars, which is also established through industry support. Now coming to wind profiler radars, we have MST radar in Gardangi, Tirupati, operating at 53 megahertz. We have BHF wind profiler radar at SHAR, operating at 49 megahertz. And we have also established a UHF wind profiler radar operating at 430 megahertz, which is scalable. It is installed in ISTRAC, Bangalore. Now these are the photographs of the tracking radars and the MST radar, which is already operational in various parts like Sriharikota and Gardanki. And this is the photograph of the UHF wind profiler radar installed on the rooftop at ISTRAC, which is operational since 1 year. It can give wind profile till 10 kilometers, and it will be very useful for studying the atmospheric parameters and wind parameters, and it can be scaled up. This also has been established with the support of industry. Now there are various subsystems which are used in radars, which can be supplied by the industry. Some of them I have mentioned, like antennas, transmitters, then TR modules, then solid state modulators, then receivers, automatic gain and phase compensated receivers, then FPGAs, DSP, signal processing, digital receivers, then signal processing for processors, algorithms for pulse compression, FFT, and what a wide range of activities that are going into the radar subsystems that can be realized by industry, and the design and analysis simulation can be given, guidance can be given by radar development area. And coming to, this is the typical specifications of a C-band radar, DWR, which is operating at 5 gigahertz. And various weather data products are required. So after the radar is operational, the imageries have to be generated, which give the reflectivity and horizontal, vertical reflectivity, velocity, differential reflectivity, then spectrum width. All weather parameters have to be processed and displayed as imageries. So this is a sample imagery that cyclone, all the cyclones which occurred last year, like Titli, Fetai, Fani, and all these cyclones were captured by our radars across the length and breadth of the country. So this is Fetai observation, Fetai cyclone captured by the radar in Sriharikota. So this is a kind of images we give that will tell whether the cyclone is moving towards north or south, what is the reflectivity, what is the velocity in which it is moving. All these products have to be made from the radar data. This is also a very important and challenging activity for the completion of the radar. And as I told you, during the severe floods that occurred in Kerala last year. This has appeared in the story of the week. ISRO Doppler weather radars located in Trivandrum and Cochin, they captured the flood, and it was providing support for the rescue operation. And these radars are operated 24/7, and we cannot afford to have any downtime for the weather radars, because weather information is very crucial and very demanding, and we cannot take any lenience or any delay as far as weather information is concerned. So the reliability of these radars had to be very high. They cannot fail. They should have sufficient redundancy, and they have to operate 24/7. Now coming to ongoing projects, we have successfully completed the upgradation of magnetron-based X-band DWR at NARL to SSPA based, that is solid state power amplifier based. That is the state of the art thing in radars now. Everybody is moving on to SSPA because of the compactness and other advantages. So ISRAG is developing SSPA based C and X-band DWRs through industry, and this is a tower based state of the art design which will be deployed for national use. So I'm briefly giving the specifications of SSPA based Doppler weather radar. This is also having coverage beyond 250 kilometers, and the power is also very high. So it's a challenging task to develop such a complex radar, but industries are capable of developing this through our guidance. Now coming to new projects, debris tracking radars and multiple satellite telemetry system. These are the two futuristic projects that we are handling. So in order to establish end-to-end capability to detect and track space objects and to safeguard our national space assets, that is our satellites, one project has been formed called NETRA, Network for Space Object Tracking and Analyzing. There is lot of debris threat now. Nowadays, the number of satellites and debris is very high, that space is very crowded. It is more crowded in certain orbits like geostationary orbits. So there is always a threat that a debris will come and hit our satellites, and our satellites can go bad. So in order to protect our national assets like satellites and even space stations, even our human space program and all, debris should not be the cause for any damage or any threat. So debris tracking radars are gaining importance worldwide. So ISRO also has taken the step to build sufficient tracking capability by establishing debris tracking radars and optical telescopes, and also to establish mechanisms for space situational awareness, analysis, control and mitigation. So, and this way we can collaborate with other spacefaring nations for sharing this tracking data, because space is common for every nation. So if we have some useful information regarding the debris, and if we share with other nations, it is like international cooperation. So the project will elevate ISRO as a participant or as a partner in global efforts in SSA information exchange by sharing observational data on resident space objects. This is called resident space objects. So as part of this debris tracking NETRA project, a radar is proposed with capability to track 10 centimeter object at 2000 kilometer altitude, and towards this we need Indian industry's support to develop such a complex and very advanced radar. So these are the photographs of existing debris detection radars. As told by my previous speaker, only 3 countries have the expertise in building these kind of radars: US, Russia and Europe. So they are highly complex and advanced radars which can detect debris and predict in what is the size of the debris, in what direction it is moving, with what velocity it is moving, how can we mitigate it. There is a lot of hardware, software tracking and analysis involved in this. So this is a very complex and challenging project which ISRO has taken up. Now coming to the specifications of this kind of debris tracking, debris detection radars, these are the specifications of the available tracking radars in various bands, and most of them, some of them are in L band, some of them are in X band, some of them are using phased array, some of them are using parabolic dish. So it is there in various configurations, and we are also trying to build a state-of-the-art and complex radar towards this. Now there is another project that is being proposed and it is planned with industry support, that is multiple satellite telemetry system. So as you know, in ISTRAC, our tracking station, we are using conventional single parabolic reflector antenna based ground stations for telemetry tracking and commanding of satellites in LEO and MEO orbits. There are many low Earth orbiting satellites, remote sensing satellites and science missions. So many of them are coming up in large numbers. So this reflector based antenna and telemetry system is dedicated to single satellite, and at a given instant of time it can track one satellite, and visibility comes when it comes above that particular station. So since the number of satellites are going to increase exponentially in the future, we have to move on to electronic beam steering and digital beam formation techniques and phased array radars to track these satellites. So this multiple satellite telemetry system is conceived, and it is planned with many capabilities such as simultaneous downlink communication from multiple satellites, as many as 200 satellites it can track with electronic steering, and it can track any satellite in any location at any direction in the sky by adopting state-of-the-art technology to cater to the large number of future satellites which are going to be built by ISRO. So this is also an advanced and challenging project which will be realized with industry support. So I'm listing out some of the industry partners. This is not an exhaustive list. Many of the partners are in the pipeline, and we are also talking to many vendors. So this is only a gist of the list of vendors who had partnered with us for the development of various tracking and weather radars, and we are also thankful to this Indian industry for having for their contribution in various forms, in various hardware and various subsystems we have realized with their help. So this is one of the support which we have sought with industry. And coming to some specific activity, we have developed TR modules with Astro Microwave, and we have also developed SSPA based DWRs with data patterns, and we have also taken the services of Logic Fruit Technologies and Wavelet Technologies, and we have some more partners coming up in the area of digital receivers and RF receivers. So we are thankful to this industry. So with this, I have just given a picture of what ISTRAC radar development area is doing, what they have done, what they are presently doing, and what are the future projects which are envisaged, and what are the support we can have from industry. Thank you for your patient listening.
Thank you, madam. Moving on to the next presentation, I invite Mr. Guruvinder Singh from Chandigarh, SCL Chandigarh.
good afternoon to all of you. So I am from Semiconductor Laboratory, Chandigarh. Some of my colleagues from VSSC are told about what are the product in semiconductor area we are making. So semiconductor laboratory is near in Mohali, Punjab. It is near Chandigarh. So we have a different technology, means it started from 3 micron to presently we have 1.18 micron technology, 180 nanometer technology. So in this we are, in the SCL, we have full-fledged in a one roof from starting from the design, fab, process, testing, assembly, quality assurance, and we are giving the full-fledged product to our ISRO centers. So many of the products are red hard products also, which are compliant to TID and single event effects. So we have different category of devices: load drop regulators, standard digital interface circuits, data converters, memories, detectors, ASICs, and MEMS devices also. In power management devices, we have low dropout regulators, we have programmable bias generators, we have LDOs, high voltage LDOs, 20 volt and 50 volt LDOs. So, and output is programmable, you can program any voltage. In standard digital interface circuits, we have some of the devices which are already obsolete in the market. So, but our centers require these devices, so we have made them available. These are some counters, registers, tri-state output buffers, multiplexer, demultiplexers, and 16-bit buffer, trans receivers, hex buffer, tri-state octal buffer, and like small circuits like NAND gate, hex buffer, some interface circuits like RS424, 422, and 485, LVDA driver receivers. These can work up to 1.2 Gbps high-speed serializer, deserializers. In data converters, we have 24-bit segment delta ADC, and we have a data acquisition systems also where the 16 ADCs are there and 24 DACs are there. So we have high-speed ADCs also. These are pipeline ADCs, so which are 14-bit and 12-bit, some low-power ADCs. We have memories also, SRAM, starting from 256 kilobit to 2 MB SRAMs. So we have detectors, which we are planning to use in different our missions, like frame transfer CCD, 12K TDI. We have photo multipliers. We have ASICs, which we have given to our different centers, like Red Hat CMOS camera configured ASIC. It is used in the Chandrayaan Vikram lander. There are 4 cameras are there. So you may have already seen the pictures taken by using this CMOS camera configured ASICs. So they are pictures from the Earth and the Moon, which are there in the internet. These are using this device only. And we have a Vikram processor, which we have delivered to VSSC for our launch vehicle applications. These are the different ASIC like OBC. This is for radar imaging satellites. And we have a Navik ASIC also. So you can see this one Navik basement ASIC. Its plastic version also we have indigenized using indigenous Indian market industry. These are timing sequencers for detectors, and we have under India chip program we have made the Ajit processor using with the IIT Mumbai and Shakti processor with IIT Madras. In MEMS, we have different type of sensors, starting from temper sensor, humidity sensors, gyroscope, and we have a pressure sensors also. We have in test capabilities, we have ATEs, automatic test equipments. We have a probers to test wafers. And we have a packaging facility, we have a different type of wire bonders, dicing facility, and a packaging facility are there in our facility. We have a reliability and quality assurance group where the different type of test systems are there, like thermal shock chamber, constant acceleration chambers, mechanical shock, pin test, different, all tests which are covered in the MIL standard 883, all required for military devices and space grade devices, all are there in our facility. So for industry participation, because we have a from design to product delivery, so we can participate with the industry MSMEs. And like in design, we can participate for development of EEPROM, flash memories, high-speed ADCs, 100 megasamples and above, and high-resolution ADCs and DACs, analog front ends, CMOS detectors, IR detectors. Any of the industry can participate for the design of these activities with us. In the package development, as you can see, all the packages which we are using, these are ceramic packages, and we are importing these packages from Kyocera and all. So if some industry can participate with us, so they can develop this type of packages for us, then it will be a good opportunity for that. We are also making multi-chip modules where on a single package, multiple dice will be there. So these are also we are importing from outside. If industry can participate in this. We are procuring the probe cards from the imported parties only. So we are procuring blade. Actually, two types of probe cards are there. One is blade type of probe card, another is epoxy probe card. So for blade probe card, we are procuring ceramic blades, and epoxy probe card we are getting from outside. If some industry can indigenize this, so that can be very useful us. These we are regularly procuring. And for in the fabrication, we are procuring number of gases, like from starting from carbon dioxide, krypton, xenon, means 30 type of gases are there which we are procuring. So if some industry can support, all these are semiconductor grade materials. So if some industry can support in these materials, because we are importing most of the material, these gases we are importing. These 32 type of chemicals are there, starting from the hydrochloric acid, hydrofluoric acid, the nitric acid, IPS, all are semiconductor grade chemicals. Maximum we are importing. Wafers also, N-type, P-type, and standard wafers, argon annealed standard wafers, these are also we are procuring from the outside only. So in the package development, so like for Navik baseband receiver, so we have developed with the industry partner 144 QFN package, that is plastic package. And also for one chip was there modem, 164 pin modem, that we have developed the 168 pin BGA plastic package. These are done using the industry support from the India only. These are some of the parts required for our foundry. So these we have indigenized using Indian industry, that are water cooled troid, molybdenum chamber, some graphite parts, and for pressure sensor the diaphragm. So these we have indigenized developed by industry support. Thanks. This is for
Thank you, Guruvinder. Moving on to the next speaker, and it is the last speaker of the session. I invite Mr. Kaushik, Deputy Director, SATNAV, ISRO Headquarters, Bangalore.
Good evening, dignitaries. My presentation is the last, but this presentation is different from what our other speakers from ISRO had given. So there they had shown the capability within ISRO, what we have that they have shown to that. But here my presentation will be the capability what you have, what you can do for us. So my presentation will be more on that, what role you can play in proliferation of Navik. Because the GPS has become synonymous with the location-based solutions across the world. even though we know that GPS is American satellite, American constellation. So actually it has been called as a GNSS. Most of you know that because you all are all the electronics field people. Okay, so now I will just, before going to the what we can do for you or what you can do for us, I will give a brief introduction of what a NAVIC is. So NAVIC was initially started during 1998 Kargil war, wherein GPS was denied to India, and we had a lot of issues related to the during the war. So even before that, there was some study going on satellite-based augmentation system, but this took it on a war footing mode post 1998, and this IRNSS, Indian Navigation Satellite System, was formed because we want to concentrate only for our Indian need. We don't need to go outside the globe. We need to be self-reliant and not dependent on others. So we started in around that time, and project was approved in 2006, and we completed the constellation in 2016, 7 satellites, and Prime Minister declared it as NAVIC, navigating with Indian constellation. So these are the frequency bands which is catering. We could get only the coordination for L5 and S band, though GPS is using L band, L1 band. And we have done evaluation, and even though our specification is 20 meters and 50 nanoseconds, we could achieve this much for a assured accuracy in a primary coverage area. So to achieve this, these are the major 3 segments. One is the space segments, which is operational. 7 satellites are available, and there is a ground segment, and this ground segment is there at the main control center is at Bangalore, and we have other monitoring stations, range integrity monitoring stations at various locations across India, as well as now we are trying to reach to the outside India also. Even though this, in this slide you say that space segment and the ground segment is big, but a smaller one is the user segment, it's good, but that is the biggest. That is the one which you can you can do a business, and you can know that now it is this era where there is a advent evolution in the communication and also information technology. So LBS, location-based systems, are taking a prime slot. So this is the coverage of the NAVIC, and very recently we could get a better position accuracy even in Indonesia. So we have the results also. And secondary coverage is of 6,000 kilometers. This also is we can cater, but there will be a compromise in the accuracy. Now that satellite systems are in place, so the system in space ICD is available in our website, and it can be used for your applications development. Now, what are the avenues of opportunity? It is all known to every one of us. Start right from the smart city to IoT, and a combination of IoT and smart city projects, and fleet management and geo-tagging. So these all are there are a lot of innovations, and lot of work is going into that, and lot of revenues can be generated from this. So we have to see how we can replace the GPS with NAVIC or coexist, add NAVIC along with the GPS. So that is a request from our side to all the industry here to see how you can integrate NAVIC into the system. So now this is the categorization what we try to do. There are many categorization of how the you can strategize your marketing. So one is the everyday users, that is whatever wearables are there, personal trackers are there, and those are the everyday users which you can directly go to the end user. The other one is the intermediate users are like if you are having a drones or a ship or even a trains, you just give the system to them and it is they who take care. So you can cater to those sector. And third is the niche users. These are the people who need for high accuracies and for for research and development where they need a very high accuracy level of millimeters level, and and they are all very small in numbers, but they are also very important where we can have put Navic into that. So other way of showing is this. See, if you can see the power versus precision. So we need to have a very low power and relatively medium precision for our regular use for personal trackers and other things. So which is a high volume, but it is a low cost. So major emphasis can be on this, so where you can have a good business. The other one is a low volume with a high cost, which is having the continuous operating reference stations as well as the RTK systems and those systems where it needs for geodetic applications. So those are the low volume but high cost. So those are the areas which you can see and try to introduce Navic into that. So as an initiative, we have actually a few chip manufacturers have already brought out the Navic enabled chips like Alista, Broadcom, Quectel, Skytrack, Telit, and U-Track. So all these are now on the vehicle tracking systems, and which is having a form factor little bigger, but it doesn't come into the mobile phones. So how to get into the mobile phone? So you need to, and also let me add from our own indigenous chip developed by SCL, semiconductor laboratories. So they have done 180 nanometer, but that is not adequate. We have to go below 10 nanometer if we want to put into a mobile phone. So we need to see indigenous, fabulous indigenous companies who can come out with some solution wherein we can get the Navic into it. And there are many areas where ISRO is trying to put Navic for societal applications. One such application is the Navic messaging receiver, which most of you, I believe, know this. This system uses a unique feature of messaging system available in Navic, unlike GPS or any other GLONASS. Right now, Baidu is coming up, and as well as Galileo is coming, but we have already put the messaging system in place, and we have started using along with Incois. So Incois, normally they send the alerts, disaster or warning alerts to the ports nearby. So fishermen, before venturing into the sea, he will see that how is the wind velocity or the tide, how is the tide height, and also if there is a cyclone. So those messages he will see, then he will venture. So this, if he has gone into the deep sea, where there is no, and you don't have any communication link. So how we can get the information? There is no way to get any communication to him. So we have made, what we have done is we have introduced and we have made one receiver which can receive the messages from the Incois. Incois sends through our satellite, through the satellite control center, and through which the satellite broadcasts those messages through the receiver. All receivers will receive it, and the receiver is connected to a Bluetooth, through a Bluetooth to a mobile phone, and in mobile phone there is an app which can display all the emergency messages. So basically the alert messages are the prime focus behind it, and added to that we can give the geofencing. This again application oriented. we can add more and more features to that, but more important is the messages of what is cyclone, what is the status of cyclone, how it is coming. So is one such application which we have, which I am showing here. Apart from that, we have the two-way communication systems are available, and also two-way messaging systems we are bringing up. So these are the other two technologies which we are trying to establish and trying to give it to the industry for mass productionization. And this again we are informing each and every fisheries department at various state governments, saying that this particular system is available and the industries can be approached to getting the units ready. And the volume of this particular receivers and this requirement will be something like 2 lakh units for to cover around 9 coastal states across India. So this ICT is also available, which we have put in the website, which can be accessed. Now, what is expectations from the industry around turnaround time? So around 2 to 3 months. So now we have just classified into 3. One is very quick turnaround, medium turnaround, long lead items. So in a quick turnaround, how you can realize some applications. So there where you need not get into any development of any hardware or any chip, anything. Available chip, whatever the chips are available. With that, you can see whether that can meet the applications. You have to do some tweaking into your software and try to use it. For example, like vehicle trackers, fleet management, which is already available, whether you can use this Navic into that. So that you can come up. Another one is within 6 to 12 months is about the basically on the drones. So drones and also the IoT, wherever there are, and also in a timing solution. Now a lot of people are using GPS time, even ATMs, banks you take, or even ATCs and many other users, TSPs and ISPs, they use GPS time only. So if we can move to the Navic time is already synchronized to NPL IST. So they are the custodian of the IST for disseminating IST in India. So you can, as an industry, you can see that how you can proliferate Navic into it and try to make business out of that. And next is a 1 to 2 years, the long lead. Long lead is into, again, right now we are in L1, L5 and S-band. So now our next series of satellites, 1IJK, LMN are going to come with L1 band, so that we can be interoperable with GPS. So you can start targeting into wearable devices. So you can have a wearable devices with those, and it will be excellent. And also to target to the restricted services for the strategic users with ASIC development. Right now 180 nanometer is there. If you can bring it even less, so they can the requirement for the strategic users is sitting in Siachen. He needs to get the information, and he has to hold it with less weight. So those are the areas where you can target. So eventually we have to coexist with with the existing GNSS. So we have to migrate totally from multi-GNSS to only Navic in India. So how ISRO can help? So ISRO can do a transfer of technology. We have 2-3 already in pipeline, like Navic messaging receiver is there, and also with regard to the restricted services receiver developments. So if you can come out with whatever proposal to us, we will look into it and see whether we can do a transfer of technology. And also for that you need a testing facilities or troubleshooting or any antenna range measurements or such facilities, simulators, because very recently AIS, Ministry of Road and Transport had given a mandate for all the commercial vehicles to be fitted with the vehicle tracking with panic button, and in conformance with AIS 140. So AIS 140 in turn has mandated to use Navic in all the vehicle trackers. So all those vehicle tracking manufacturing agencies, they didn't have a simulators, and so they sought help from ISRO. We provided them the help, even though they are approaching us. So as of now, around 83 models are available in Indian market with Navik. So this has to increase, it has to increase only. The other one is we can collaborate piloting. You can do any, if you come in with a proposal, we can do some piloting systeming, and if we want, we can support a back ending also. And if we need to, for any for your sustained business, if you need to have a policy or mandating or not licensing, you please approach to us. We are ready to take it and listen to you and try to give a solution. And also to the user base creation also we can do. And the last one is the NRE, and also the those things also, subsidies also can be thought of. So what benefits? Benefits to ISRO is, yes, it's our own constellation. Navik is our own constellation. So your service is assured; it will not be denied at any time. So there is 24/7 availability, because this particular constellation is in GSO. So it's always available, and the one advantage is that it is in for a cities. We have done this experiment also, that wherever the cities are there, where high-rise buildings are there, there could be a loss of signals in the GPS, because GPS in the middle MEOs. So those move from one. So since it is moving, so there could be loss of signal. But since Navik is in GSO, always it's available for your. You will not lose any signal. And in fact, with when we did a test in Ahmedabad, we found that at the urban canyons, as well as very close to the places where there are some tunnels, subways, the chipset with Navik was performing better. And you will have an access to the ISRO's resident expertise. We are available, and for any technical assistance required. And for any future, for any government projects, if you want assistance from ISRO to help you out, we are ready to do that. And last but not the least, then we can try to use the ISRO Navik brand. So with this, I conclude my presentation. Before that, these are the Mr. Raghu is our director, and his email ID is here, and Mr. Manish Saxena is the industry interface. So, and I am Kaushik, I am taking care of the user segment. So we three, you can approach any one of us. We will listen to you, and we'll try to give a solution. Thank you.
Ladies and gentlemen, I'd like to request you to please give all the speakers a big round of applause from ISRO, HAL, and BEL. I'd like to request Mr. Rahul Arya, Executive Council Member, Iesa, to present a small token of our appreciation to each of the speakers from the ISRO technical session. We'd like to thank Mr. Sudhir Kumar. I'd like to request him to please come up on stage and receive a small token of our appreciation. Thank you, sir. I'd like to invite on stage Srimati S. Tenmoli, Executive Director, HAL. I'd like to invite on stage Srimati, AGM, BEL. Srimati Subbalakshmi Krishnamurthy, I have reason to believe she is left, but if there's a colleague of hers or anyone representing her in the audience, if you can just come forward and receive it on her behalf. I'd like to invite Suma Santosh. I'd like to invite Gurvinder Singh. And last but not least, I'd like to invite on stage Kaushik. We'd like to thank Rahul Arya for giving out the mementos. Thank you. Well, ladies and gentlemen, we're not going to be recessing for tea and coffee. I think most of you already grabbed your cups of tea and coffee. If you haven't, those of you who haven't, request you to please grab a cup of tea or coffee and please bring it back with you into the hall. We're going to move into the next session. We have the talk on outsourcing of space projects, learnings from other countries. We have with us this afternoon Reena Raman, Vice President and General Manager, Embedded Acceleration Division, Data-Centric Group, Intel Corp. Ladies and gentlemen, please extend a warm welcome to Reena Raman.
Good afternoon. I want to thank, first of all, Iesa for the opportunity to come talk to you. I appreciate that I've been given this opportunity. I'm actually very excited to be here, to be able to discuss this with you. It's an honor and a privilege, and thank you for listening to me as well. I'm excited because India has actually come a long way in space. I'm very excited to see how much India has invested in space. Personally, for me, I was born in India, but my family, my parents moved away to the US when I was 11. So I'm Indian by birth, and India's my birth country, but America's my adopted country. And so it's an exciting time for me to come see what happens here in India. And the other thing that I also always find is that, you know, when you look at space, what people really find, I think, exciting about space is the unknown, the frontier, something unexplored. It really provokes all of our imagination. But in addition to that, it also gives us a perspective of ourselves, because when you're out there in space, you get to view us from out there, and you get a view of us from a different perspective. And I feel that's what I'm getting being here amongst all of you, is a different perspective of India from afar as well. It's been exciting watching the progress India made in space and the Chandrayaan-2 project. I think everybody was watching it, you know, with avid, you know, bated breath up until the last minute. And even though it didn't go completely 100% as planned, it was still a huge accomplishment for India. India is one of only a handful of countries to even get into the orbit and get to the moon. And the other part that I found absolutely very touching was the response of the nation to what wasn't a perfect mission, in the sense that when at that last moment, in that last 100 meters, things didn't quite go the way it wanted. Obviously, everybody saw on national television the disappointment that the leaders of ISRO, like Dr. Sivan, felt. And it was even more touching to me, like the next day when I saw the cartoon in the paper and in the news of a outstretched Mother India embracing Dr. Sivan, and it speaks to the nation's strength, the nation's character, that you embrace, and I think really spoke, characterized how the whole nation felt, and how you embraced somebody who was a leader and who had actually made a huge amount of progress, and even though it wasn't perfect. So kudos to India and for having that strength of character. So I have to, of course, start out on being part of a large Intel organization with a legal notice, and I'm sure you'll all very quickly read that and know your rights as well. So having witnessed what the world has accomplished in terms of the space industry, I'm really glad India is investing in space and appreciating the challenge and taking on the challenge. So coming from the US, on US soil, I can tell you about what's been happening. So NASA's planning to send astronauts back to the moon, and the plan is for this to happen in 2024, 4 years ahead of what their original plan was for the Artemis project. And since the first time that somebody went to the moon about 50 years ago, actually almost exactly 50 years ago in 1969, humans haven't really been back since 1972 to the moon. And there's been, in the last 47 years since somebody's been to the moon, there has been a huge amount of progress in terms of technology. When I look back 50 years ago at that first moon landing, the Apollo's guidance system computer ran at only 1 megahertz. Could you imagine? The guidance system ran at 1 megahertz. And the Intel 8086 processor wasn't even around. In fact, it wasn't around for almost 10 years after the first moon landing. It was almost 1979 before the Intel 8086 was around. And in fact, these 8086 processors were actually used for a host of diagnostic and equipment in the first space shuttle in 1981, and was also used for about the next 20 years until the components became, were hard to replace. The replacement parts were hard to find. And what really this points out to is they were really pioneers, and what they had to work with back then versus what we have to work with now is amazing. And space is harsh. It's harsh for microelectronics, and it's harsh for humans. And in order to be able to ensure the successful missions, NASA and other government entities have actually started studies and looking at the effects and the experiments to mimic the conditions and environments in space to prepare our astronauts for the venture. And Intel has been partnering and involved in some of the research and helping influence the technology evolution for the future missions. And we would love to be able to partner with you as well. One of the areas that Intel is involved in is NASA's Frontier Development Lab. And this is a public-private partnership between NASA and Iesa in Europe, the SETI Institute, the institute that studies for terrestrial life, and the commercial space like SpaceX and Blue Origin, and also AI computing. Or AI companies, I should say. And this is so that we can prepare for the next lunar landing and next lunar mission so that we can help with decision planning and when we send astronauts back into the moon. FDL in particular has been chartered with solving some of the most complex space mission problems with the latest AI technology. Items like lunar resources, lunar mapping, Earth observation, as well as space weather. And the format of this lab is generally an 8-week accelerator, and with experts, like normally 2 AI experts and 2 planetary science experts in key challenge areas. Intel has supported 3 of these teams in the 2017-2018 timeframe for a total of about $285,000 of sponsorship. And then in addition to that, we have in 2019, Intel and Google have each contributed about $500K to cover 8 different challenges for NASA FDL. This includes the US FDL as well as the Iesa FDL in UK. And then there's normally about 2 designated mentors who will bring Intel subject matter experts to advise the experts, advise the teams as the team progresses. And some of the results of this research may also be applicable on Earth. So for example, there's a disaster prevention challenge that happened in 2019. And the team looked at flood detection and flood, augmenting flood action. So what do you do once you detect? How can you quickly and possibly give satellites more autonomy? And then there was also a research on the interaction of the northern lights, which is normally a phenomena near the north, like we see it in Alaska or some of the Scandinavian countries, with GPS outage. And so they looked at the correlation between those. And the results of that are actually being published at the end of this month on September 30th, and it'll be an open source document for anybody who wants and is interested in reading about it. And the other area where Intel has been involved is with DARPA. We've supported the DARPA Subterranean Challenge to autonomously map the tunnel systems underground. So we sponsored NASA Jet Propulsion Lab entry with real-sense cameras for their advanced wheel rovers, which is called a Husky, and drone and rover hybrids, which are called rolocopters, and JPL partners with Caltech, MIT, KIST, which is in South Korea, to build these robots. And then the team actually won 2nd place this year in the first competition that happened in August of this year. So the idea of this challenge is for smarter mission planning, applicable for space exploration, as well as for first responders. You know, I think back, personally, this sort of excites me, not just because it's space, and everybody finds space exciting and what we could do there and what we could find there, but also the applications here on Earth. I think back to about a year ago. I'm sure most of you remember, because I know everybody in the US and everybody that I spoke to in different parts of the world as I traveled around were glued to the TV, watching with complete concern as there were 12 young boys that were part of a football team in Thailand and their coach that were trapped in a maze of underground caves, which was filling up with water. I don't know if most of you remember that, but you know, it was very heart-wrenching. People weren't sure if they were going to make it. The boys were scared. The messages that they got back, you could see how scared that they were. You could see how scared the parents were. You weren't sure if they were the children were going to live. And it really, I think, touched the heart of everybody in every part of the world. And the way they actually went about the rescue process was they had to first send in divers, like experienced divers, you know, that were capable of doing scuba diving, not just scuba diving in the open ocean, but scuba diving in an underground cave where you don't know the path, it's really claustrophobic, you might not have enough light. And they had to first map out the whole terrain. And they could only map it out sections at a time because they would run out of oxygen in their tanks, so they would go as far as they could, map it out, and then they would come back. And then another team would go. And they first had to map out the whole thing. And in the whole process, they also had to take food over and supplies over to the kids so that they could keep going while they were figuring this out and figure out the best way to bring these kids out. And these kids weren't expert scuba divers, so they had to prepare them, practice with them, and then bring them out. Now, and you know, the Thai Navy SEAL, a hero, Samam Kunun, actually lost his life in the process of saving these kids. Now imagine if you could have this done autonomously, and if you could have a mission where you could use robots in the rescue, where they could actually go out and map the whole thing out, what it would do for you, right? So that's one of the reasons I find this challenge super exciting, is it's not just what it can do for you in space, but what it can do for us as humans here on Earth. And then as Intel, we get more involved in these kinds of research. We're being asked for more help to bring Accelerator to space. And we are happy to assist in whatever way we can. And we want to partner, as I said, not just with our partners in the US in terms of NASA or in Europe with Iesa, but we would also like to partner with ISRO here in India. There you go. Oh. So now that I've gotten you excited about Intel's involvement in space research, I wanted to kind of go over a little bit about Intel. For those of you who are not familiar, it is probably the largest semiconductor company that's been around for a long time. It was actually originally started in 1968, so over 50 years ago. And it was founded by Robert Noyes and Gordon Moore. And Noyes and Moore left Fairchild Semiconductor, where they were working to incorporate a new venture, and which they started out calling it NM Electronics, but then changed the name to Intel over the course of the year. In terms of size of the company in dollars, it is last year at 2018, the revenue was $71.5 billion in revenue, which was a record high for us. And the revenues contributed from key business units that are shown below. So you can see actually the different products at the very bottom that Intel makes, and all of these products contributed towards the $71.5 billion in revenue from Intel. In terms of size of employees, there's 107,100 employees as of the end of 2018, and approximately 50% of these employees are located in the US, so which means the other 50% are elsewhere in the world. And here in Bangalore alone, we have about 8,000 people at the Intel facility here in Bangalore. And approximately, when you look at the whole global workforce, about 87% of the workforce are actually technical. They're in technical roles. So very much a technical company, very focused on engineering, and huge commitment to R&D. So when I look at Intel's commitment to R&D to maintain our leadership position in semiconductor manufacturing, and our prevalence in data center technology, as well as our investment in AI, we invest $13 billion each year in R&D alone. So $13 billion in 2018, right? And so it's among the top 5 companies in terms of spending for R&D. And there's about, if I look at, we obviously make semiconductor chips, and if I look at the semiconductor chips, our largest gate count or transistor count in our latest generation product had over 200 million had over 200 million transistors in one chip. Okay, so I hope that gives you a little bit of a breadth of what we are about. And as you can see, we have products in the client, so which is like your laptops and your PCs and such, which is where we originally started, to data centers, which is where our company's transforming and evolving into. We're looking at new technologies. You might have seen some of the Intel drone shows. If you haven't, you can YouTube it. Go look at the Intel drone shows that we put together with Intel drones and Intel drone technology. Memory solutions with our Optane memory, artificial intelligence solutions, programmable solutions with FPGAs, as well as our Internet of Things IoT solutions as well. So the other thing that I would point out about Intel is most people think of it as a semiconductor company, and that's our roots. That's where we started. But out of the 107,000 plus employees that we have, over 20,000 of them are in software. So almost a fifth of our company, almost 20% of the company writes software. And so, which is what I think is a little bit unknown to most people and always a very interesting thing to look at. And we actually work on software on many different levels. We have OpenSwitch, FlexRAN solutions, OpenVINO. OpenVINO is a platform that allows us to actually write code that could target a processor, or it could target an FPGA, or it could target our Movidius vision and video solutions. now that I've kind of given you a little bit of breadth of what we do, I want to talk a little bit about the division that I belong to. The division that I'm part of is called the Network and Custom Logic Group. So we do ASICs, structured ASICs, like from the company Iesa that Intel acquired last year, as well as FPGAs. And the main areas that we focus on could span anywhere from the edge, all the way from the smart device edge, all the way through wireless networking, multi-access edge computing, core network, all the way to the cloud. And part of what is really interesting about this is if you look at the breadth of Intel's products, they generally fall into one of three categories, or actually in multiple of these three categories, but these are the three that we focus on, which is move, right? Moving data, so the networking part, you're moving data either through Ethernet or silicon photonics products, et cetera. Store, which is like our persistent memory Optane DC products or our solid state drive and our other memory products. Or process, which has been the traditional bread and butter of Intel in terms of either processors, Xeon, Atom, core processors, or FPGAs for acceleration, or Movidius processors as well. And then on the right side are our software products in the form, as I mentioned, about OpenVINO and DPDK. So with the different products that we create, Intel's actually able to offer an end-to-end solution. So as an example, you could start at the endpoint there in a video processing example, and you could use a Movidius chip in your camera that can go into gateways, that can feed into a gateway. That consist, and the gateway can consist of a processor and another Movidius chip or an FPGA. And you can do most of that processing in the gateway before you send the data to the data center for storage or further processing. This is really important because first when cloud became popular, people thought they were going to send all the data up to the cloud, and the cloud was going to do all the processing and then send you back the final answer, so to speak. But I think as people have moved towards this direction, they're finding that maybe I don't want to send all the data to the cloud for multiple reasons. Number one, privacy concerns, security, but also latency. If you're sending all of your raw data up to the cloud, it's going to take a really, really long time. So maybe you want to do some pre-processing in a gateway closer to the edge, and then decide what do I want to send out into the cloud. So that's part of what we're offering here. And then it doesn't just provide the chips, but the software framework as well that supports all the chips that were listed there. Okay. Now that I've talked to you a little bit about the background of Intel and the products that we offer, I'd like to talk a little bit about what are we doing to accelerate challenges with FPGAs in particular. So here we use a Xeon processor along with an ARIA or Stratix chip to be able to do workload optimization. So depending on the workload that is prevalent in a particular system, what we're finding today is systems are not homogeneous anymore. Systems are really heterogeneous because you could have different workloads that come into the system, and depending on the workload, a GPU might be a better solution, or a CPU might be a better solution, or an FPGA might be a better solution, or an ASIC might be a better solution. So if you have the option of one or more of these and being able to pick and choose and put together your system with a wide variety of choices, you're more likely to be successful in your system. And that's basically Intel's strategy and approach, is that we offer a multitude of offerings, everything from the CPU, FPGA, Movidius, processing, ASICs, as well as GPU functionality. And then in particular, these are the NCLG offerings, everything from the lowest cost and lowest power CPLDs with the Max, to Cyclone, which offers cost and power balance, and also the Cyclone offers SoCs. So there's Cyclone 5 SoC, as well as transceivers are built into these Cyclone devices. And then in the mid-range, we have ARIA, and ARIA also comes with option of FPGAs or SoCs, including transceivers. And then Stratix, which is really our higher end devices, which are optimized for bandwidth. And then our latest 10 nanometer product that was released and shipping to customers earlier this year, Agilex. And a structured ASICs, which I mentioned before, was acquired from a company called Iesa. And this allows you to have half the power at half the cost of a equivalent FPGA type design, and supports higher volumes as well. And we also offer power products in the form of Empyrean power regulators and power products. All right, and on the bottom there's a list of resources that allow you to take advantage of some of the offerings on top. So there's embedded soft core and hard processors in the form of Neos and ARM. So the embedded SoCs have ARM in them. We have design software in the form of Quartus. That's the design tools you would use to actually program the FPGAs. Because I always say the FPGAs are like a whiteboard. You can write whatever you want in them. And we also give you the software along with the chips. They're like the pens that allow you to write on that whiteboard. And it's only limited by your imagination. And development kits and COTS boards, which allow you to do development on the boards. Programmable acceleration cards. These cards have both Xeon processors or other Intel architecture processors paired up with an FPGA for you to be able to accelerate your workloads. And then reference designs such as pulse Dopplers or RF front end, matrix inversions, and design separation, which you can use as a starting point to do your own designs. And we offer a rich partner ecosystem to be able to support your local needs, that the partners are present here, local, indigenous, to be able to do designs with you. And as I mentioned, Agilex is our latest and greatest product. It's on 10 nanometer. It allows you to process data with up to 40% higher performance than previous generation, up to 40% lower power. And in terms of DSP performance, which is really important in space and defense applications, it has about 40 teraflops of DSP performance. It allows you to store data. It supports DDR5 as well as HBM memory, as well as the Intel Optane DC persistent memory support. And then allows you to move data through 112 gig transceivers, which is the leading transceiver rates in the market. No other FPGAs have products at those rates. And also we have Intel Xeon processor coherent connectivity on board the FPGA, so you can connect to a processor very quickly along with PCI Express Gen 5. The other thing I want to quickly point out about the Agilex architecture is that we use the EMIB technology to marry tiles to our architecture. That you'll see the different colored tiles around the periphery. And the yellow there shows the EMIB that connects the fabric in the middle to those different tiles. This allows us to add new technologies that come in different spaces, in different markets, very quickly onto our single packaged device. All right. Also, in terms of simplifying bring up and lower cost, it allows you to do complete power management on the power rails, including our Empyrean device with the Agilex. It allows you to save space and reduce cost and achieve advanced performance. And we actually have complete out-of-the-box solutions pre-done for you that you can actually download from the website down there, intel.com/Empyrean. So this is the complete continuum. We offer FPGAs so you can first get to market quicker than anybody else. You have flexibility while you're still figuring out your design, while the market is still being set. And then once you have your design set, you could optimize it for time to market, because it's relatively easy to move to a structured ASIC, eASIC, and at half the cost and half the power, and so maintain your performance. And then if your volume is high enough, you could move into a full-blown ASIC with the highest performance, lowest power and cost. And we can support your design all the way through the entire product life cycle. Okay? And these are the different vertical applications that I'm responsible for in my division. I focus on these markets, and as you can see, the radar and defense and surveillance are key parts of areas that we focus on, and just in general, military, aerospace, and government. Okay. And in particular with defense applications and solutions, here are some of the areas that we're focused on: ground and naval electronics, rugged systems and devices, avionics, as well as looking at communication networks, avionics flight safety, vehicle and electronics, unmanned systems, training simulation, command and control, as well as ruggedized systems and devices. And we offer solutions in all the areas listed on top, and the ones on the bottom, we have use cases and applications, and we can work with a partner to develop solutions in that area. All right, so with that, I think the message that I really want you to leave with is, number one, Intel provides a unparalleled breadth of portfolio, everything from high performance compute and connectivity, agile and flexible AI acceleration, and anything to anything heterogeneous chiplet integration, so CPU, NVIDIA's GPU, FPGA, eASIC, and a proven Intel eASIC device customization path. And the second message I really want to leave you with is that we are very committed to helping you in your efforts, and however we can help you, please reach out to us and let us know. And then last but not least, October 8th and 9th in the US, near Washington, DC in Maryland, we have what's actually called the Federal Summit. We will have many organizations from the US government present there. And it's our 5th annual Intel Federal Summit. And you can learn from the world's foremost technology innovators about solutions in this space, and meet many of your counterparts in the US, and also benefit from our partners who are using Intel technologies to deliver breakthrough intelligence. You can also discover emerging mission-specific solutions before they come to market. So these are things that we have not announced. These are things I'm not talking about here in my quick 30 minutes, but these are things that you can find out with an NDA. And you can also find out answers to reduce your costs and more efficiently implement your solution and accelerate time to market. And if you're interested, please look at federalsummit.intel.com for more details. And thank you.
I'd like to thank Reena Raman. I'd like to request Mr. Anil Kumar, past chairman Iesa, to present a small token of appreciation to Reena. I'd like to request all of you to please give her a big round of applause once again. Our next speaker is Andrew Glascott-Jones, Field Applications Engineer, Teledyne, E2V Semiconductors, France. Ladies and gentlemen, please extend a warm welcome to Andrew Glascott.
Thank you very much for inviting me to speak to you today. It's humbling to be here. This morning, it kind of hit me home that all the achievements that the Indian Space Agency and the Indian ISRO and those guys have done. It was quite emotional morning. So thank you very much for inviting me to speak a little bit about my experience in the space industry and what we do and what Teledyne E2V Semiconductors does. I'm a field application engineer for Teledyne E2V Semiconductors, and my job is to help customers use our chips. We're a semiconductor company, we produce chips, and my job is to help those people use those chips in their applications and to understand their applications. Our market is in the high reliability market. And so that means that a great many of my customers are space customers. So I'll try to give some examples of where outsourcing. I've seen examples of outsourcing where it's worked. I'll give a little introduction about Teledyne in global, and then some more details about Teledyne ETV semiconductors. I've got a couple of slides about my view of the space market in Europe and how outsourcing helps that market, where it can hinder it a little bit, and the rationale behind outsourcing in the space market in Europe. And then a little bit more detail on Teledyne semiconductors, what we do, the kind of products that we produce, and what kind of applications we go in, and then a quick summary. So here's globally Teledyne in space since the 1960s. It was on first the Apollo missions, produced hybrids as part of the Apollo missions. Then we were on the space shuttle with hybrids as well, also geospatial imaging pods, the special build by part of Teledyne that did special systems, also on the Hubble Space Telescope. And then part of the product line that I'm involved with, that's Teledyne E2V high-rel electronics. Well, they have specialist space-grade RF components, and so they were used on some scientific experiments that flew in the 2000s. And then we come right the way through to a more module, a subsystem effectively, which you can see there, number 10. And I'll speak a little bit more about this on the next slide. But that's for the OneWeb constellation. So that's another part of Teledyne that has produced subsystems for the OneWeb constellation. And that's an example of where outsourcing and the new space market has helped that particular part of Teledyne to grow. Now, this slide is a little bit focused on part of the Teledyne organization that isn't so much involved with the products that come out of Teledyne ETV semiconductors. So I've added in here the effect that where some of our products have been used. And you can see these two devices here. That's a high-speed DAC, 3 gigasample per second DAC, and a high-speed ADC, both space-grade. The ADC is 1.5 gigasample per second, and now they've been sold in their thousands, FMs in their thousands, and they're in pretty much every high-throughput satellite that's flying now, and they're being designed into the next lot of high-throughput satellites, and also Earth observation, synthetic aperture radar systems as well. So these are really great products, and they're heavily used in traditional space systems. And we're working with ISRO using these components as well. And then we are introducing gigaflop processors for space applications as well. So these are the new application areas. And I won't go through the product line, but I'll give you some ideas of where we're going in those particular product lines. Now this is the company that I was speaking about. They're based in the UK. They're part of the Teledyne organization. They're part of Teledyne Defense and Space. And they were experienced in RF small filters, RF subsystems, some electronic warfare systems. And then, thanks to outsourcing, thanks to the new space market, and I've got a definition that's from actually the director of marketing of this company, and he says the new space market for him is customers' willingness to negotiate some risk on the individual subsystem for a reduction in cost, and a willingness to negotiate with somebody who hasn't got space heritage. So from this company's point of view, they negotiated and they won a bid for a part of the OneWeb system, and that was, I think, 2016, 2017. What you can see from, this is a slide that the director gave me, this part of the slide here. And in 2017, their market, their space market, was that small circle. And thanks to that, and thanks to an expansion in capability and investment, they now can look for business in a much wider area. So there's one of the positive aspects of outsourcing and the new space market. So enough about another Teledyne business unit. Now we'll speak about my Teledyne business unit. I'm Teledyne E2V Semiconductors, and we produce semiconductors for high-rel applications. Our strategy is, in the main, that we partner with other companies who have already produced the component, the silicon, the gallium arsenide, whatever, and we screen it, qualify it, repackage it, and produce it for high-rel applications. Civil avionics, military systems, and space. And our partner companies, NXP, Peregrine, ISSI, GaN systems for power FETs, some memory companies as well. The one part of our IP portfolio that we design ourselves are the data converters. And that team is based in Grenoble in France, where I'm based as well. So we provide this range of products for high-rel applications and have a wide footprint in the space market. Now, I've got some slides here that are my view of the space market in Europe, and they're based on my interactions with these companies. I've certainly missed some companies off, and I maybe have put a company in the wrong tier, but it's just to show that the way the kind of food chain operates, and there's an equivalent diagram that I've got for the new space market, which is slightly different. So you can see the final client up at the top. That can be, if it's a telecom system, it's one of the big telecom operators, Inmarsat, Eutelsat, SES. Final customer could be Iesa for one of their space probes, Flex, Juice, Prober. So they commission the scientific mission. Or it could be governments for their military satellite, military telecommunication satellite, or Earth observation satellite. And in general, those final customers will look at a prime to be the prime. And in Europe, there are three primes: Thales Alenia Space, Airbus, and OHB. Probably Thales Alenia Space and Airbus are the major primes in Europe. And in particular, for the telecoms operators, they will look to the primes in Europe, but they'll also look to the primes in the US. So they'll also be looking at people like Boeing and Space Systems, Loral, and those kind of people. So once the project's been negotiated and it's in the prime, then the prime will be looking at individual subsystems. And a gentleman earlier today from ISRO gave some indications that was also the case in ISRO, that strategic equipment would be designed in-house, and less strategic equipment could be subcontracted out. And that's often the case with the primes. So they will go to other companies like RUAG in Austria or Sweden, Leonardo in Italy and the UK, or Kongsberg in Norway, to do subsystems like data links, up-down converters, and frequency generation, that kind of thing. Surrey Satellite Systems, that's an interesting company, because they kind of almost started the new space market a while ago, and they're now part of the Airbus group, and they're sometimes a prime. They've been a prime for some satellites. I think Quantum telecommunication satellite was built by SSTL. And then below the tier two, these are companies that will have a specific a specific experience, a specific ability in a particular domain. For example, Terma, ASP, they're really good space-grade power supplies. Antwerp Space, Data Links, Omnisys, that's scientific experiments using microwave receivers, that kind of thing. So that's the way the food chain goes in the traditional space. And then in the new space market, and here's the quote from my friend, the director at Teledyne Microwave in Shipley. So for him, new space, there are lots of different definitions of new space, but for him, it's a willingness to negotiate risk for a cost reduction for a particular system. Obviously, in a constellation, although the risk for one of your satellites is higher because your components haven't been screened so much, because you've got so many satellites spinning the Earth, it doesn't matter if one goes down. So for the overall system element, the risk will be acceptable. But for a satellite in that constellation, the risk that it fails could be higher. It's interesting here that from what I see, the final client, well, we've got SES, they're producing O3b with OneWeb, Telesat. Some governments, that's the Italian Space Agency, they've commissioned a kind of a new space satellite. And that's really to show off the capability, and they've contracted it out to Italian companies, and that's to show off the Italian space competence with this, I think it's 2 or 3 satellites called Platino. So some governments do get involved through their space agencies. I won't go through a lot of this, but the point is that here you can see Sealinks. That's a French company that was producing data links for avionics systems. Now, that was able to move into the space arena thanks to the new space market. Otherwise, it probably would have stayed where it is. So there's an advantage there in the new space market, bringing in new companies. And also, we see Sideral there. That's a traditional space company, and also a new space in the new space market. And we see the same Ruag and Kongsberg are also in that market as well. So now a bit more information about Teledyne semiconductors. As I said, we produce a range of components from RF components using Peregrine space products. I've got a slide that shows that very quickly later. Power solutions for the space market. High-performance processors based on a partnership with NXP. And we design ourselves the ADC and the DAC. Here's a highlight. It gives you some idea of what we do with high-speed data converters. This is our most recent ADC. It's a quad 1.6 gigasample per second 12-bit ADC with a serial interface. And this is space grade. It's also in the same package. It's also an industrial grade part. So here we can with this part and different levels of screening, we can produce something that will go in a 15-year mission, or we can produce something that will go in an oscilloscope. So that's the strategy that we have to try to bring together the requirements from different markets. And technically, we can interleave the 4 cores. It can go up to 6.4 gigasamples per second. The real highlights for it are that it's got the synchronization feature that allows a multi-element system of ADCs to be very easily synchronized without any external components. So the synchronization signal can travel from ADC to ADC. That's not like that in systems that are around right now. There needs to be a fan-out chip to do that job. So with this synchronization feature, we can take away that chip and reduce system cost and reduce system power as well. And the other interesting feature of this chip is the serial interface. We've not gone with traditional serial interface for high-speed data converters, which is known as JSD204. We have developed a protocol that we call Easy Stream, efficient serial interface for high-speed data converters. And the advantages are it uses less resource than the FPGA. You could compare there, you know, a fifth of the resource on a transmit and a third of the resource on receive. And so that has an impact on the power of your system and also of the resource required in the FPGA. So it goes a long way to making systems less power hungry and more efficient. And the other direction that we have with our data converters is that we want to expand the frequency that the data converter can operate in. That's the analog frequency. This means the strategy here is to put the data converter as close to the antenna as possible. For an example, we have a DAC that right now can convert signals from baseband using the alias feature, the aliasing phenomenon, right the way up to K-band. And when you've got something like that, it means that this part, you have a traditional system that would have an up-converting mixer, a local oscillator. You don't need it anymore. You can cut that out, and all you need is a bandpass filter around the signals of your interest, and then the standard power amplifier, and the signal goes out. So you can do a direct conversion to K-band, and that's got advantages of flexibility. You reduce the size of your PCB, you reduce the number of components, that improves the reliability, and you reduce the power of the system. So this is the direction that we are going with our data converters. I've not put the product list up there, but it should give you the highlights and where we're going. On the processor side, what we're offering now, this is based on the partnership we have with NXP. We are offering NXP processors based on either PowerPC, the first two up there, then the second two on the left, they're PowerPC-based parts as well, and the newer processors from NXP are based on the ARM core. And the difference between these processors and, let's say, a Leon processor, which is totally rad hard, is the performance that you can get out of them. We're looking at those two processors there, the 8548, looking at 5 gigaflops, the 7448, maybe 10, getting towards 10 gigaflops. These two here are above 10, and then the LS1046, that's 30 gigaflops of performance, processing performance that you can have on your satellite. And David Gambo was speaking earlier on today about having that processing performance on the satellite. That gives you advantages that you don't need your data link to be overloaded to the Earth. You've got much more real-time control, so real-time control for robotics on the satellite is possible. And you can do real-time processing, let's say for synthetic aperture signals. You don't need to send the raw data down to the Earth to have it analyzed. It can be done on the satellite. And then if it's done on the satellite, if you see something interesting in real time, you say, oh, that's interesting, maybe we can take a zoom in on that. So that's the advantage. I mean, I heard that some experiments, some NASA experiments were being canceled because they were producing too much data and there wasn't enough bandwidth on the data link to the Earth to make the experiment useful. Now, doing some kind of data compression using a high-power processor is a good idea. And there's a success story for the PC7448. That's gone onto a weather satellite, and this particular processor is part of an imaging system. It's looking at the lightning that occurs on the Earth and getting information about weather patterns from that. So here's another part of our portfolio. This is RF gain blocks, power amplifiers, and this is a mix of full space grade parts, so ceramic package and the full screening, and some upscreened parts, some plastic upscreened parts. I've got one slide that shows you how we're trying to match up these differing requirements from new space and traditional space markets. Here's our power offer, and again, it shows that we have traditional space parts with ceramic packages, point of load circuits, and FETs for DC switching. You see there's a ceramic package version available, but also we have the standard plastic package version available with extra qualification, extra screening for space COTS applications. And that's what we try to do. Sorry, this one. Okay. Oh, sorry. There's one slide gone off there. But, so I'll have to describe the slide to you now. The slide was showing you how we adapt between the requirements for space COTS and traditional space. We have two options. We either don't do as much screening for a traditional space part, or we upscreen an industrial space part. So they're the two options, and that's what we try to do for our individual customers. It's the same silicon, but there's a different level of screening involved. The one thing that is kind of always required by space COTS application, new space application, is a knowledge of the radiation performance. So that's really a prerequisite for a part to be in the space COTS arena. It needs to have a good radiation performance. And as long as it's got that, then which screening is done, which qualification is done, depends a lot on the actual application and the orbit and the lifetime of the mission. So here's the summary. From my view, it seems that the traditional space market is quite structured. Every company in that food chain has good experience and knows a lot about the market that it's particularly in. There is, for some of those companies, particularly the tier twos, there's some reliance on central funding. So some companies are really dependent on the funding of Iesa, and so they really need to make sure that they get the next project through Iesa. The traditional space standards, they're well known. You've got documents, QMLB, ESCC 9000, they're very well known. But could be for newer companies a slight barrier to entry to that market. Now, the new space standards, there's no new space standard. As I said, radiation performance is probably the only requirement that I'm aware of that's applicable to all space applications. And so it's very much on a case-by-case basis. And so we can tailor the amount of screening that's done for a particular application depending on the requirements of it. And so, as I showed you the example of Teledyne Microwave, outsourcing has provided companies to expand their portfolio, to expand their area of interest. And from my point of view, as a component manufacturer, we need to adjust to these different quality levels that are being required by our customers. So that's my summary. Thank you very much for listening. And
thank you very much indeed, Andrew.
Thank you.
I'd like to request Rahul Arya to please present a small token of appreciation to Andrew Glasgow-Jones.
Thank you. Thank you very much. Oh yeah, we need to go to the middle. Thank you very much.